important. But now we are going to discuss about channels, okay? And this is equally important. Actually, everything that you will study here is important, and everything is generally asked, okay? So once you go through that, you will understand that once you go through the problems and everything, you will understand that, okay, everything is actually very, very important. So now the next topic that is here is, okay, let me just see if the recording is started or not. Okay, so recording has been started. So next thing that we are going to discuss is DMS, that is discrete memoryless, DMC, that is discrete memoryless channel. That is discrete memoryless channel. Okay. So I mean, all of you kind of, we have an idea of what a channel is. Okay. I mean, what is channel? Can anybody tell me? I'm not looking for a correct answer. I'm simply want to know what you know. Okay. So what is channel in your opinion? Anyone?
Anything through which we can share information.
Anything which through which we can share information. Okay. Now in, like, it's basically a path or medium through which the symbol flows to the receiver, isn't it? From transmitter to receiver. It's a path, isn't it? Through so a discrete memoryless channel. When we say a discrete memoryless channel, it basically a statistical model, okay, with an input X and an output Y. Okay, so when we are talking about discrete memoryless, channel, then what we have a what you can say input X, okay, and then we have our output as Y. Okay, so this Y can have some symbols, and similarly this X can have some symbols. Okay, so this X is source and this is, so you can think of X as transmitter or Y as receiver. Okay, so when we talk about discrete memoryless, this is what we talk about. Okay, during each unit of time, the channel accepts an input signal or input symbol uh, from X, and in response it generates an output symbol Y. The channel is discrete when the alphabets of X and Y are both finite. It is memoryless when the current output depends on only the current input and not on any of the previous input. So discrete means, what discrete means, that we have let's say discrete number of input symbols, that is, let's say x1, x2, x3, x4, all the way up to, let's say, x of m. Okay, so these are m input symbols, and similarly you can have your output symbol as y1, y2, y3, and can be all the way up to y of n. So you can have n output symbol. So what happens, as you have already as I have already discussed, that जब भी कोई इनपुट देता है, accepts an input, channel क्या करेगा? So this is channel, anything that is in between, and I will tell you how I'm going to model it. So this part, this is the path, okay, and that is going to be modeled as a system, and I will describe about this system. So whenever you get it gets some input from X, it generates in response, it generates Y. Okay. So X1 मिला तो ये Y1 generate कर सकता है या X1 मिला तो ये Y3 generate कर सकता है depending upon different things. Okay. Depending upon channel model and all these. Okay. And this channel is modeled since this is a statistical model. It is generally modeled in terms of probability. Okay. And the probability that we are going to model it is y of j divided by x of I. So y of j given x of I. Is this clear? So this is how we are going to model this. Okay, so a discrete memoryless channel is going to be modeled by this. So when we have discrete means our input and output x and y is discrete. We have finite number of values there. And when we say memoryless, then we mean that it doesn't depend upon the previous value. Okay, that what it means. Okay. So this is the diagram that you have already seen. Okay. Um, and okay, so this uh, mm, probability is Pyj divided by xi is generally called as channel transition probability. Okay, so let me just write this here. So this is going to be called as channel transition probability. Okay, and so we generally model this for a discrete case by a matrix, and that matrix is known as transition probability matrix. Okay, so or sometimes channel matrix. So let me just write it. It's more popularly known by channel matrix only. So let me write that only. Channel matrix. Okay. So what is channel matrix? Channel matrix basically consists of channel transition probabilities. Okay, and it is given by P of capital Y given capital of X. Okay, and this is denoted by a matrix. So let me just write this in terms of matrix only. Okay, so here you will have your P of Y1 given X1, and then you will have P of Y2 given X1, and similarly, how many in Y? We have N, right? So P of Y of N given X1. Okay. Here in the second row, it's going to be P of Y1 given X2. Here you will have P of Y2 given X2 all the way up to dot 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 P of Y of N given X2. So similarly, it's all going to be down here, and here you will be getting P of Y1. How many N we have? M, right? So X of M. So row is kind of denoting your input, and this column is denoting your output. So in column, you see that you have Y1, Y2, Y3, and in X you have in the row you have X1, X2, X3. Okay, so this is how you can do this. So this is going to be P of Y of 2 given X of N. Sorry, yes, X of M have. So this is X of M. Okay. And so on dot dot dot, and here you will have P of Yn given X of M. So this is the channel matrix. Okay, and I mean it's self-explanatory. There is nothing more that you will discuss here. Now there is one thing though here is that so each row, if you look at each row of this channel matrix, okay, then you will see that it is kind of it's a distribution in itself. If you take on row of each of the row, you will see that this is equal to 1. So we will see that once we will have some example. Okay, so I mean, अगर आप row को देखेंगे, तो you will see that this will sum to 1. Okay. Now, so this is channel matrix. Similarly, we represent our what you can say um, input probability as a symbol probability matrix. So P of X is also represented in terms of a matrix. So this will be represented in terms of a row matrix. Okay, or you can represent it in a column matrix, but I would like to represent it in terms of row matrix only. So this is written as P of X1. Then second you will have P of X2, P of X3, all the way up to we have M symbol. So I think kitne symbol the? Yes, M symbol. So we will have P of XM in input, right? Similarly, your output symbol matrix P of Y is given by this P of Y1, P of Y2. Okay. And final value is going to be P of Yn. Okay. So this is N output symbols and M input symbol and their probabilities. Okay. Now, if I have to calculate, let's say P of Y. So this is P of Y comma X. This is channel matrix. Okay. So from here, let's say I have to calculate P of Y, then P of Y will be written as, okay, we write this as PD of X times P of Y by X. Okay, and what is PD of X? Where PD of, I mean, this is something that you have already studied, so I'm just simply elaborating it here. How we are going to do this? This will be PD of, so this is going to be P of X1, and then 0, 0, 0, all these are going to be 0. Then you will have here 0, and here you are going to have X2 and 0, 0, 0. So it is basically a diagonal matrix 0, 0, and P of X3. Okay, and all these are 0. I mean, there may be more. There must be dot, 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 dot something, dot, dot somewhere, and dot, dot, dot. Finally, you will have 0, 0, 0, 0, dot, 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 and here you will have P of X M. Okay, so this is the diagonal matrix M by M diagonal matrix, which diagonal elements contains the probability of X1. So if you multiply, you will get the value of Py. Okay. But let me just discuss this. So this is P of Y X, Y by X. And let's say I have to compute this value of Py1. How am I going to do that? कैसे मैं करूँगा? I have to compute the value of, let's say, P of Y1. So how I'm going to do that? Okay. So anyway, just when we will solve problem, this is all going to become very clear. Next, we have what is called a joint probability matrix. So this is another important thing, joint probability matrix. And this is written as P of X, comma, Y. Okay. So this will be equal to, sorry, I made a mistake here. Sorry, this is not good. I will simply multiply with P of Y to get P of X, right? I will discuss this. Okay. I will simply multiply with p of x to get p of value of p of y. Okay. Let me just cut this. Okay. And p of x comma y is generally calculated. Let me just post it here. To calculate p of x comma y, okay, we multiply here with pd of x. Okay. So sorry. So this is going to be pd of x, diagonal matrix of x, into p of channel transition matrix, that is p of y by x. Okay. So by this you will be getting this. Let me just cut this again and okay. So this is our joint probability matrix, and it's quite easy to do. You have already done this kind of when you will do dealing with two variables, random variable. You have already done this. Okay. Only thing is that I'm representing everything in terms of matrix so that it's easier to manipulate. Okay. So this is what all these things are. Now we are going to discuss some of the entropy that we will have to deal with. Okay. So the very first entropy is channel, so what you can say, uh, h of x, right? Or input entropy. So various entropy that we deal with. So the very first entropy is h of x. And this is defined directly as summation. You already guessed it. Like this is very simple. P of x I into, you will have log of 1 upon p of xi, isn't it? I is equal to 1 to m, since we have m symbols in x. So this can also be written as minus I is equal to 1 to m. If I take p of xi, 1 upon pxi can be written as pxi to the power minus 1, and then minus 1 can be outside. So this will be written as p of xi log uh, p of xi. So this is just simple. So this is how you will be calculating. Similarly, you have your output h of y, and h of y is written as, again, I is equal to 1 to, we have n symbols here, let's say in output. So this will be p of yi, I is equal to 1. So yi into log of 1 by p of yi, and what we can do here is then again we can represent it like this only. So minus I is equal to 1 to n p of xi into log p of xi. Sorry, sorry, this should be y, right? So this will be p of yi into log p of yi. Okay. So these are the two input entropy and output entropy, you can say. So this is for input symbol and this is for output symbol. Okay, for the input source, or you can say output receiver, transmitter or receiver, whatever you want to call it, you can call it. Okay. And after this we have uh, you know so after that let me just discuss this one. So the third one here is going to be your h of x. This is generally written x comma y, and this is called joint entropy. Okay. And this is its formula is again in the same manner. Let me just do this. So this is written as j equal to 1 to n, and then you have I is equal to 1 to m, and here you have p of xi comma yi, and then you have log. Uh, all these are log base 2 only, so I haven't written, but this is something that is we have already discussed in terms of entropy. So we take this base in 2 only most of the time, unless or otherwise is specified, and this is going to be log base 2 p of xi comma yi yj. Sorry, this is y of j, xi and y of j. Okay, so is this clear to everyone? So these are the three entropy that you have to understand. Now you can directly calculate other entropy as well. For example, you can calculate h of x by y. Okay, so this is x by y is again written like this, minus j is equal to 1 to n. Sorry, I is equal to, this is I is equal to and j ही होगा 1 to n. J is for y, right? So n. So you will have j is equal to 1 to n, and then I will be from 1 to m, and you will have this only. So p of xi comma y of j, and times log base 2, and here you have probability not p of xi yj, but instead of that you have log base 2 p of y of j. So we are calculating this, right? X by y. So we will have x by y. So this is going to be xi divided by y of j. Okay, so this is how it is calculated, but you will soon going to find out that we seldomly use all these formulas simultaneously. So that's kind of a benefit here. Similarly, h of y by x will be written. So I'm not deriving these formula, though you can easily do that. I mean, just follow the definition of entropy and you will be able to do this. It's not going to be very difficult. Okay. So this is going to be h of y by x is going to be j is equal to 1 to n. Similarly, I is equal to 1 to m, and you will have this p of xi yj log base 2, and now since we are calculating um, y by x, so it will be yj divided by x of I. Okay, so these are all the entropy related to channel, and this is all that is you have to calculate, and in most of the question you will be asked all of them. Okay, so if it's a theoretical question, then you will be asked to calculate all these. Okay, but it's actually very simple. Their relationship is very simple, and let me just define this relationship here. So now I'm going to define the relationship, and you will have to kind of pay close attention here. So h of this x comma y joint entropy is equal to h of x by y plus h of y. Okay. Similarly, the same thing, x comma y can also be written in terms of h of y by given x plus h of x. Okay, so this is the relationship that you have. So once you calculate h of x, h of y, and h of x comma y, you can easily calculate h of x divided by y using this formula, and we don't use these formula. Okay, so इनको हम लोग कम we rarely use करते हैं, but we use these formulas. Okay, so they are much easier to remember, and I'm not going to give the detailed how to prove them, but you can easily do that if you go through textbook or something. These proofs are going to be given there, so you can easily determine these value as well. Okay, so this is something that is already given. Now let me discuss the meaning of them. What is the meaning of these all these entropy? So what does hx represent? Can anybody tell me what is entropy? Randomness, measure of randomness, right? Isn't it? So what is hx? a measure of uncertainty, you can say. So this measures what does HX signifies?
Average
What is X?
information.
Average information, right? Very good. So uh, this is X is input of the channel, right? Isn't it? So this is average information of the input, or you can write this average uncertainty. So information is uncertainty basically. Regarding channel input. Regarding channel input. Okay. Similarly, what is going to be your h of y? What does this denotes? This is average uncertainty of channel output. But is that clear? Now, what does h of x by y denotes? So you say h x given y, right? So when output has been observed, how much remaining uncertainty is there in the input? That will be measured by this h of x by y. So this is average uncertainty remaining after remaining about input after observing the output. Okay. And what is h of y given x? This is the average uncertainty remaining about output after observing the input. Okay. And here hx comma y is average uncertainty of the communication channel. Okay. So this is average uncertainty of the communication channel. Okay. Now, after just getting to know these meanings, these formula has, I mean, uh, entire different set of what you can say, uh, interpretation. You can look at this. So this is the whole channel and uncertainty, and that is equal to uncertainty about y and uncertainty about input x when y has been observed. Okay. Similarly, this can also be written as uncertainty about input, then uncertainty about output when input has been observed. Okay, so this is very easy to understand once you understand the meaning of these things. Okay. Now after that, we are going to so do remember these formula. They are very, very important. So while solving problem, we will be using them a lot. Okay. So after this what we have is something called as mutual information. And this is a very important quantity here. Okay, again, I'm not going into a derivation of this, but I will simply be discussing the formula that is generally used. So this is defined like this. So let me just directly write down the formula. So this is written as I of x semicolon y, and this is written as h of x minus h of x given y. Okay, and I mean this, you will see that if you look at this, then it becomes very clear. So this can also be written as, since it's going to be symmetric, it can also be written as h of y minus h of y given x, isn't it? And this is also written as h of x plus h of y minus h of x comma y. Okay, is this clear? So I of x comma y is equal to I of y comma x. So that is kind of commutative. So you can already see that I of x comma y will be equal to, this is the same thing. Okay, and this is always greater than equal to 0. That is another thing that is there. Okay, and the mutually, let me just write this, what this means. So the mutual information, so the mutual information represents, so what is h of x? In uncertainty about x. What is x given y? Uncertainty that remains after observing y. Okay, so what is h of x minus h of x comma y? It is the amount of information that you got after observing y about x. Is that clear? So represents the uncertainty about the channel input, about the channel input that is resolved after observing the channel output. And I'm going to represent them with a Venn diagram here. So that will be very easy for you to do. So let's say this is one. I'm going to draw another one with different color here. Okay. So we have this part here, which is, oh sorry, I have, so this is the intersection part here. And so this part is, and let me represent this by blue one. Okay. So this whole green one, so whole blue one is your h of x. This whole green one, complete green, okay, h of y. This intersection here is your I x semicolon y. I hope that this is visible to you. Let me just write this from here to here. This is I X semicolon Y, that is mutual information, and this whole thing, this whole union. So union is your basically h of x comma y. Okay. So this is very easy to remember. Now, I mean, if you remember the formula, what is going to be h of x comma y? This is basically h of x plus h of y minus ix of y. And what is ix of y is going to be h of x plus h of y minus, I mean, you already know this formula, isn't it? A union B ke terms mein, right? So this is, if you represent it like this is what you will be getting. Is it clear to everyone? Is this clear? And now let me just do this a bit bold here. So this part, which is only blue, and I mean, this is not in Y, isn't it? So this is h of x given, uh, sorry, yes, h of x given y हो जाएगा ये, and I think this is going to be h of y given x. So, I mean, finding out these are also very easy, you can see. So from here, you can see that.
See, this Venn diagram is very important, and it will help you a lot.
You will have to kind of understand this.
Yes. If you forget sometime the formulas, then it will help you to understand, to remember the formula.
So you see that you have to determine h of x comma y, then you can take this green part, that is h of y by x, and this whole blue part, isn't it? So h of y by x plus h of x. So that is the formula that, I mean, with this you can remember all the formulas. Okay, what is the relationship between the rest of them? You see, these two formula can be directly derived from this. Okay. You have to determine union, isn't it? So you will take this green part that is not in the blue part, and then you take the whole blue part, that is h of x plus h of y by x. You have to determine h of x comma y in terms of this. So you can take this blue part h of x by y, which is not in the green, and then after that you add this green part and you will get your h of x comma y. So all the formulas that we have studied till now in terms of entropies relationship and mutual information, that can be derived from this Venn diagram only once you understand this. Okay. And it's very easy to understand. It is built upon something that you already know. Okay. So I hope that you will remember this. Okay. Next, I'm going to discuss about channel capacity. So, I mean, let me just discuss this. Channel capacity and channel capacity, I mean, it is basically channel capacity per second and channel capacity per symbol. Okay. So we have channel capacity per second. Let me define this. So channel capacity per symbol, and it is generally denoted by C of S, and C of S is your maximum value, okay, of mutual information. Okay. Let me just write this P of xi here as well. Okay. So when maximization is over all possible input probability distribution on x, then you know this is going to be your channel capacity per symbol. Okay. And similarly, your channel capacity. So I mean, this is generally not asked very much. It's basically function of, you will see that channel transition probabilities. Okay. That defines the channel. So it's very easy to do. We will see one or two problem and it will be quite easy. And the second part is channel capacity per second. And if R is the rate that we have already discussed, then C is going to be R time C of S. So this is channel capacity per second. So CS you have already determined, and if you multiply this with R, this is the channel capacity per second that you will be getting. Okay. And let's now discuss some of the channels that is there. I mean, though you can do that on your own, I don't really have to do that, but I think you will be able to do that quite easily. Okay. So I think we should discuss channel capacity theorem now. Okay. So I'm not going into detail of that as well, and we'll just discuss the formulas only. Okay. And then after that, maybe I will, after that I will discuss the channels. Okay. So this is the third law of Shannon. So I have skipped the second law. You can do that on your own. So this is channel capacity theorem, or simply known as Shannon-Hartley law. Okay. Capacity theorem, or sometimes known as Shannon-Hartley law. Okay, it's the most important theorem. Even in GATE examination, this question based on this formula is asked very often. Okay, so in every second times you will see that this question will be asked in GATE examination. So you can be very sure that you will get a question based on this. Okay, so this says that, I mean, you have channel capacity C, and this is the channel capacity per second. So C is related to bandwidth of the channel. Okay, like this. So channel capacity is equal to bandwidth times log base 2, 1 plus S by N. Okay, where S by N is signal to noise ratio. Okay, is this clear to everyone? Bits per second. Okay, so this is the channel capacity theorem, and this is what it says. Okay, कि आपका ये है रिलेशनशिप सिग्नल. सो किस किस चीज में ये रिलेशनशिप बताता है आपका? So this gives you relationship between what quantities? Channel capacity what is the second quantity that you are seeing here? Is bandwidth of the channel. And what is this third quantity? Let me highlight this first, and yellow. Okay. And what is this? Can anybody tell me now? This is signal to noise ratio. And this actually equation solves quite a few what you can say problems, or quite a few questions. Let's say that our channel has infinite bandwidth. Okay. Then will its capacity is going to be infinity? Can its capacity be infinity if the bandwidth is infinity? So what it basically says that, it's kind of develops a understanding between, what is the role of bandwidth, what is the role of signal to noise ratio, how much they are required for channel capacity, and what is going to be the capacity of the, channel based on that. Okay. So you will see that there are quite a limits that is generally derived from this formula. So you can go through that. Even I will discuss it if time permits. But one of those question is that the very first thing that it says that if you decrease the bandwidth, okay, and then you can increase the signal to noise ratio to maintain the channel capacity. Okay. Another thing is that if your channels, if you have a large bandwidth, your signal to noise ratio can be as small as possible, and you can kind of sail through it. Another thing is that it says that even if your bandwidth becomes infinity, okay, your uh, your channel capacity is not going to become infinity. So that is something called channels sentence limit, and we will see that later. Okay, for now we are going to look through different channels that we have to discuss. Okay, so these are the channel capacity we have already discussed here, and then I just wanted to just give you where this is going to be used. So this is where it is going to be used generally, and now we are going to discuss about this different kinds of channel that we have. Okay, so what are the different kind of channels that you have? There are different channels you may have already studied in your practicals. So types of channel or spatial channel, let me write this. Spatial channel. Okay, so the very first channel that I will be discussing is a lossless channel. Okay, and lossless channel is something like this. Let me just draw the diagram first, and then we will discuss about this. So lossless channel is like this. I'm just giving you one example here. Okay, and then you will have another. Sorry. And let's say this is the third one. So in input we have 3 symbols, and in output we have 5 symbols here. Okay, so this is x1, this is x2, and this is x3, and the output symbol are, let's say, y1, this is y2, this is y3, this is y of 4, and this is y of 5. And let me give you some value here. So this is 3 by 4, and this is, let's say, 1 by 4. This is half, and this is also half, and this is, since it is mapped to 1 only, this is going to be 1. Okay, so you can see that this, what is going to be its y by x matrix. Let me just write this, or rather than it is generally written like this, matrix Mickey and the p of y by x लिखते हैं. Okay, so how this is going to be? What will be order of p of x by y? Can anybody tell me? How many rows it is going to have and how many columns it is going to have? So rows will be equal to number of input, and columns will be equal to number of output. So how many rows will be here? 3 rows, right? And how many columns? 5 columns, right? Which since we have 5 value here. So p of, you see that this probability is p of y1 given x1, isn't it? And this is p of y2 given x1. Is this clear? So this is 3 by 4, and this is 1 by 4. And x1 is not being mapped to y3, y4, or y5. It means that these probabilities are equal to 0. Similarly, for this, you see, for x2, p of x2 is not being mapped to y1 and y2, means these two probability are going to be equal to 0. And p of y3 given x2 is equal to half, so this will be half. This is also going to be half, and x2 is not being mapped to y5, so this is going to be 0. And then x3 is not being mapped to neither y1, y2, y3, and y4. It's only being mapped to y5. So all these are going to be 0, and only 5 is going to be 1. So you can see that row wise, this py by x matrix, if you add row, you will see that they add up to 1. Okay, this is 1, this is 1, this is 1. Is that clear? So this is py by x matrix. Okay. and you can determine its entropy here easily. एंट्रोपी निकाल सकते हैं आप लोग इसका. Okay, so I mean, this is the y by x is given, and okay. So why this is called lossless? First, address this question. Why this is called lossless matrix? So here no source information is lost in transmission. Is lost in transmission. So I will be writing it like this. Okay, so that's why इसको अच्छे से कर दोगे थोड़ा सा. Let me just lost in the transmission, and that's why it is known as lossless matrix. And for a lossless matrix, you will see that it's what you can say h of I think h of x by y will be equal to 0. Okay, so for a lossless matrix, what will happen? That h of x given y will be equal to 0. Okay, there will be no loss, so this must be equal to 0. Is this clear to everyone? So this is one of the property of lossless channel, and this is how we prove this. Okay, that a matrix is lossless. Is this clear to everyone? Now, can you tell me what is going to be its, mutual information? Sorry, what is going to be channel capacity of a lossless channel? So channel capacity we have already discussed, that is equal to maximum value of mutual information, and we have to find out this for lossless channel. So what this is going to be, can anybody tell me? So very first thing that you have to prove is this. So आप इसको prove करें पहले. Okay. Can you do that, or should I do this? So there are lots of small things here that is going to be left so for you to do. But let me just do this and show this that this is actually in fact equal to 0. Okay. And then you can proceed here. Okay. So this is given as P of y by x, right? Isn't it? Now, since P y by x is given, what is going to be P of x by y? Can anybody tell me? P y given x is given like this. What will be P of x given y? Let's say you see that अगर आपको y2 मिल रहा है, इसका मतलब क्या है, वो कौन सा है? It's going to be what? Let's say that you received y1. It means what has been transmitted? Can anybody tell me? Are you there in the meeting or not? So P x by y matrix these two value are going to be 1 and all these three are 0. Similarly, these two are 0, these two are going to be 1 and then 0. And here again you will have 0, 0, 0, 0 and 1. Okay, there is no ambiguity about x once you know what is your output. So once you know y1, you know that what has been transmitted is x1. So what is p of y1 given x1? By p of x1 given y1, that will be equal to 1, isn't it? What will p of x1 given y2? Y2 is received, it means x1 has been transmitted, isn't it? Similarly, y3 has been received, it means x2 has been transmitted. So there that is certain. So that's why. So you'll see that in px by y matrix, okay? So this p of xi given y of j is going to be either equal to 0 or it's going to be equal to 1. Okay, this is what I'm trying to say. And since this is either 0 or 1, what is going to be h of x by y? What is h of x by y? Anybody? This is basically equal to how much? Summation j is equal to 1 to n minus and summation y is equal I is equal to 1 to m. You have p of xi comma y of j times log base 2, and here you will be having probability p of xi given y of j. So since this value here, so this value here is either 0 or 1. So it's either 0, 0 or 1. So this whole thing is going to be equal to 0 only, isn't it? If you multiply this with, you will end up with 0 only. Is this clear? I mean, you may have doubt that, okay, when it is 0, this is undefined. Okay, so let me just to, clear that doubt. Let me write this p of xi yj as this. So this can be written as, so let me just write this like this. So this is j equal to 1 to n minus p of, here I'm going to write this as y of j and then summation I is equal to 1 to m. You will have p of xi given yj times log base 2 p of xi given yj. So either this term log 2 base, this term is 0, or this base, this term is undefined and it is multiplied by 0. When it is 1, then this is 0, isn't it? And when it is 0, this term here is undefined, but this is multiplied with 0. So you will end up with additions of 0 only, and that is equal to 0. So h of x given y will be equal to 0. Okay, and what is h of x given y? It is the entropy of x, okay, after observing y, and or uncertainty about x after observing y. But in this case, in case of this lossless channel, what is happening is that once you observe y, there is no ambiguity about x. So h of x given y must be equal to 0 here in this case. That is kind of, logical extension, but you can prove this like this. Is this clear to everyone? Is it clear? Hello? Are you there in the meeting or सब लोगों ने छोड़ दिया अभी?
Yes, sir.
Okay. So it seems to be difficult, but it's actually very easy. So you don't have to worry about that. Once you go through all this will become very simple and very easy to calculate. Okay. I hope that this is clear. Now let's try to find out what is going to be mutual information here. So or channel capacity, you can say what is going to be mutual information here. So what is going to be I of x comma y? What is I of x comma y? Can anybody tell me what is the definition that you have studied? This is h of x minus h of x given y, isn't it? And h of x given y is equal to 0 for this case. So I of x comma y will be h of x only, isn't it? Is this clear? Since this value is 0 for a for this, we are talking about this lossless channel only, isn't it? Is that clear? So I of xy will be equal to h of x only. Okay. And what is going to be your channel capacity per symbol? This is the maximum value of I of x comma y. Okay, bit per symbol. And this is maximized over input probabilities. So, I mean, under what condition this is going to be maximum? Okay, so this basically becomes here in this case, this will be maximum value of h of x maximized over input probability. And I mean, this, what is the maximum value of h of x? We have m symbols, right, in input. So this is going to be log base 2 and m. Okay, so that is the, channel capacity per symbol. So as you see that as we go case by case, this becomes very, very easy to solve. Okay. So this is one of the channel that we have. Now the next channel that we have is I think lossless के बाद हमारा कौन सा channel है? I think the next channel is deterministic channel, and then we have noiseless channel. Okay, so we are going to go next to the deterministic channel. Okay, and then we will discuss about that. Okay, and there are 3 channels only, so I think I will go over all of them. So for a deterministic channel, what happens is that you see if there is only one non-zero element in each row, okay, then that is going to be a channel matrix of deterministic channel. Okay. So once the source symbol is transmitted, you will be knowing which output is going to be observed. So let me just first represent it like this. So you will have, let's say, x1, and then this is x1, this is x2, and this is the output, let's say y1. Okay. So you see that with every x3, x4, so x3 will be, let's say, related to y1 only, and x4 is related to y. So this is y2 and this is y3, and let's say x5 is also directly combined with this, so x5. So here you will see that P of y by x matrix. This matrix is like this. Sorry. So x1 y1 में 1, x2 is also 1, and all these quantities, so y1, y2, and y3, right? So this is going to be 0. This is also, so this is also going to be 0. This is also going to be 0. And here x3 is with 2. So this is 0, and this is 1 and 0. And then x4 0, 0 and 1. x5 is also 0, 0 and 1. So you'll see this either contains 0 or contains 1. So for this, h of y by x is equal to 0. Okay. Once input is known, output is automatically known. Okay, that's why it is called deterministic channel. That once ambiguity about input is clear, there is no ambiguity about output, and that's why this is called deterministic channel. Okay, Now for this again, you can try to find out what is going to be your mutual information, and that is also very easy to do that. So I hope that you will be able to calculate this. तो क्या आएगा बता सकते हैं मुझे डिटर्मिनिस्टिक चैनल के लिए? So this is mutual information here, I of x comma y here will be equal to h of y only, h of y minus h of y by x. So y by x is 0, so this is h of y only, and so cs is going to be maximum value of this I of x comma y maximized over input. So p of xi, forget about this, this is just for symbolic. And what is the maximum value of hy? So maximum value of hy, and we know that since it has n symbols, so it will be log base 2 n. So that is going to be unit channel capacity in symbols per channel capacity per symbol, bits per symbol. Okay. Similarly, a noiseless channel is both lossless as well as deterministic. So the third channel that we are going to discuss here today is called noiseless channel. And it is both lossless. It is, you can say, lossless plus deterministic. Okay. So for this, what will happen that I of x y will be equal to h of x, and that is equal to h of y. And here in this case, n is equal to m. So number of input is always going to be number of equal to the number of output. And its channel diagram is actually very, very simple. See, there is one line. One input is connected with only one output. One input, one output. Okay, something like this. And all these values are going to be one only. Okay. Let me this is x1, x2, x3. This is x4. This is y1, y2. Y of 3 and y of 4, and all these probabilities are equal to 1. So that's why h of y by x and h of x given y, both of these values are equal to 0 here in this case, and mutual information is this quantity here. Okay. So I hope that this is kind of clear, and you can, you can determine its capacity, and CS here is going to be log base 2 m or n whatever, because m and n both are equal to 1 only. Okay. So this is going to be your channel capacity here in this case, and this is your noiseless channel. Okay. And then there is binary symmetric channel. So I'm not going there in detail, but for binary symmetric channel, you can go and verify these things. Okay. Now what we are going to do is we will be solving some problem based on what you can say. Okay, so let's the problem that I have already given to you. I'm just going to take that and we will try to solve that one. I think I have given it somewhere on the top. I don't know where. Okay, before this. Definitely before this. Okay, so this was the question. Okay. So let me just copy this and ask you some more question regarding this. Yeah, so I have kind of solved this part. So okay. I think I will have to zoom out here a bit. Okay. Okay, नहीं आ रहा. I think it will be in new page only. Okay. Okay. Forget about this. I can't write this much. Let me just copy this part only. Okay, so this is one of the example that we were trying to solve. Next question, I mean, first part we have anyway solved it. So let me just give you the second part. And the second part is that can the output of this source be transmitted over without error over an AWGN, a white Gaussian noise, okay, GN channel, okay, with a bandwidth 10 kilohertz and S by N ratio that is equal to 20 dB. 20 dB. Okay. So this is the question. The thing is here you will have to kind of समझना पड़ेगा. First part में हमें क्या मिला था? In the first part, I think our R rate is equal to 80 kb per second, kilobit per second, isn't it? So this is 80 kb per second. And now we have to, from the second part, in the second part, this is the part one. And part B, what we have to determine is we have to determine the channel capacity of this theorem. And that capacity must be greater than this rate, right? अगर वो चैनल की कैपेसिटी इंफॉर्मेशन रेट से कम हो गया तो आपको लॉस होगा. लॉस नहीं होने के लिए क्या होना चाहिए कि रेट जो है दैट शुड बी लेस देन चैनल कैपेसिटी. चैनल कैपेसिटी शुड ऑलवेज बी ग्रेटर देन द रेट एट विच इंफॉर्मेशन इज गिवन टू द चैनल. So here you have to find out channel capacity. So what is the formula here? C is equal to B log base to 1 plus S by N. Okay. Is this clear? So now bandwidth here is given to be equal to what? 10 kilohertz. And then you have a kilohertz means, let me just write this, 10 into 10 to the power 3, right? So that will be 10 to the power 4. And then you have log base to 1 plus S by N. So S by N here is given in 2 dB. So how much this is going to be in ratio? In pure ratio, how much this should be? It's 10 log से compare करेंगे तो कितना आ जाएगा? S by N will be equal to how much?
2.
2, right? So this will be कितना आएगा आपका? 10 स्क्वायर हो जाएगा, isn't it? So अभी निकाल दीजिए, मुझे बता के ये कितना वैल्यू आएगा बताइए. 10 to the power 4 into log base 2, and I think this is 101. So of course more than like 6, but 6 क्या 7 से ज़्यादा, लेकिन नहीं 6 से ज़्यादा और 7 से कम, right? So how much this is going to be? 6.66 something कुछ होगा. So 6.66 into 10 to the power 4 bits per second. Now is this more than or less than what we have? So 80 kbps means it is 80 into 10 to the power 3, isn't it? So this will turn out to be equal to 66.6 into 10 to the power 3, isn't it, bits per second? So of course this value here is less than this value. It means you can't transmit it over that channel. Okay. Now alternate question that can be asked here is like this. So these are the two questions, and let me ask you the third question. So what kind of so questions are asked like this, that find the signal to noise ratio. So we do have bandwidth that is fixed, and that is fixed at 10 kilohertz. Then you have to increase signal to noise ratio only, okay, or to increase this channel capacity, right? So you have to find out signal to noise ratio, okay. Find S by N required for error-free transmission. Okay. So find signal to noise ratio required for error-free transmission. That is the second question. And how can we proceed this? So our capacity C must be greater than this rate. This is what we know. And this capacity is given by 10. This is kilohertz, right? So 10 into 10 to the power 3 log base 2 1 plus S by N. And this would be greater than, and what is the rate? Rate is 80 kbps. So 80 into 10 to the power 3. Should be greater than equal to this, isn't it? This is what we have. So अभी इसको आगे कैसे proceed करेंगे बताइए. It means क्या आ जाएगा 10 10, so log base 2 1 plus S by N should be greater than how much? 8, isn't it? Right? So it means 1 plus S by N should be greater than this 2 to the power 8, right? So what will be S by N here? Should be greater than 2 to the power 8 minus 1. So I mean 2 to the power 8 minus 1, so greater than equal to 255. Okay, so 255 के लिए S by N in dB कितना होगा? This is going to be how much? आप निकाल लीजिए इसको, ठीक है? Okay. So this is how generally these questions are asked. Now I just wanted to complete one more thing that is generally asked here, and that this is what is called as capacity, C infinity. So again, this is a limit, and this is a well-defined limit. So let me just frame this in terms of a question only. So a determination of C infinity. Let me just write this. Determination of C infinity. Okay. So a white AWGN, okay, channel with infinite bandwidth. Bandwidth is given. Okay. It's what will be its capacity? That is the question. Okay. And that capacity is denoted by, that capacity here is denoted by this C infinity. So we are in, search of finding this value. Okay. And some other informations are given, and these information are given as that average, so average signal power. So when you have infinite bandwidth, there is no signal to power ratio, isn't it? Because the signal to noise power ratio, because bandwidth is going to be infinity there, right? So average signal power is given here as S, and eta by 2 is power spectral density, PSD. So this is two-sided power is spectral density, okay? Two-sided. Sometimes one-sided power spectral density is given, and that is represented by eta. And this, since it is represented by eta by 2, we generally multiply it by 2 before multiplying it to the bandwidth in order to get noise power, okay? Is this clear? So now our C is going to be how much? This is going to be B log, we already know there's B log 2, 1 plus S by N. And we have to kind of represent it like this, log base 2. How much this is going to be? 1 plus S, and this is eta by 2 into B, isn't it? So this will be eta times B. This noise ratio N will be equal to eta by 2 into 2 times B. Since it is 2 bandwidth, now we are taking two-sided, means we are taking negative frequencies as well. So that's why we have multiplied it by 2. So we got this quantity now. Okay. And now you have to calculate the C infinity. As B tends to infinity, you have to find out what is going to be the value. So this is the C. We have to find out C infinity, which is basically limit B tends to infinity, B log base 2, 1 plus S by eta B. Eta and B is bandwidth, okay? So what this limit is going to be, can anybody tell me? So first it is in terms of log. We have to convert this into natural algorithm in order to evaluate this value. Okay. How much that is going to be? Can anybody tell me? Okay. Now let me assume this beta. Okay. So this signal to noise ratio, let me assume this to be lambda. Okay. So let me lambda is equal to S by this eta times B. Okay. So what is the value of this B is going to be from here? Eta times lambda divided by S. Is that clear? Sorry. So beta will be here. So S by N lambda, right? Sorry. S by M lambda. This should be equal to S by eta lambda. This is the beta. I'm just trying to make this as 1 plus something. I mean, that doesn't really matter, but still. So the C infinity is going to be limit b tends to infinity, and what we have here is s by eta lambda log base 2. So I can make this log base e, and this is 1 plus lambda only. And since we are taking this, then this is going to be log base e base 2, right? हमने यहाँ 2 को हटा दिया इसलिए. So what did you have? Now you have beta tends to infinity, right? And that basically means that lambda will tends to 0, isn't it? Beta tends to infinity, the lambda tends to 0. So I can write this limit lambda tends to 0. And what I have here is s by eta lambda, right? Let me just modify this a bit. S by eta here, and then we have log base, 1 upon. So we have second quantity is 1 upon log base e2, and then we have log base e 1 plus lambda divided by lambda. And you can, I mean, you just forget about these constant, just focus on this part here. And you see that limit lambda tends to 0 here, right? So this will be equal to how much? This is equal to 1, isn't it? Right? So this term is equal to 1. So how much C infinity is going to be now? You will have 1 upon log base e base 2, and here you have s upon eta. Bits per second. Okay, so this is the, even if you have infinite bandwidth, this is the maximum capacity that you can achieve. And that's why this is kind of a limit to that. Okay, so this kind of, gives you the upper limit of any channel. Okay, and we kind of do this with upper channel के लिए अगर कोई है. Okay, so it's like that. Okay, is it clear to everyone? And since there are many other variations of this, so you will find out quite a few things here. I'm not going into detail of all kinds of questions, but you can go over each of these questions and find out how to deal with them separately. Okay, is it clear? Now let me give you some question that you can try and solve. Okay, so let me give you binary channels only, and based on that you have to find out all the entropies and related things. Okay, so let me just give you binary channel. So there is a binary channel, means like this, we have 2 input and 2 outputs. Okay, इसको properly करते हैं. So this is x1, this is x2, and this is y1, and this is y2. Okay, and the values here are given to be 0.9, and this value here is given to be 0.1. Similarly, this value here is given to be 0.2, and this value here is given to be 0.8. Okay, and for this channel, give me, so you have to find out for the given channel diagram, calculate. The very first thing that you have to find out is channel matrix. So find P y by x. Okay, and then after that determined so if the second part is if P of x1 equal to P of x2 is equal to half. Okay, so these two are given as half. Then determine h of x, h of y, h of x given y, h of y given x, and h of x comma y, mutual information x semicolon y. Okay, and anything, is there anything left? I don't think so. These are all the things that you have to determine. So can you do this? निकल जाएगा आप लोगों से? And one probability matrix, that is x matrix P of x comma y. So these 6-7 things you have to determine. Just zoom out a bit. Okay, होगा आप लोगों से? Will you be able to solve this? Have you solved this problem? Anyone? Okay, so let me just solve this for you, and you can solve the next one. Okay, so what is going, the very first thing that we have to do is determine this channel matrix. So this will be equal to how much? So this is basically P of y1 divided by x1, P of y2 divided by x1. So let me just write this, P of y1 divided by x1, and this is P of y2 divided by x2, and then here you will have P of y1 divided by x2 and p of y2 given, sorry, this is x1, sorry, x2, and this is pi of y2 given x2. So x1 this is. Okay, so how much this is going to be? From here diagram, you simply write 0.9, this is 0.1, and then this is 0.2, and this is 0.8. Right? So this is the channel matrix that we have. Now P of X is given. So let me just write this. So what we know, so we have P of X matrix. So let me just write this. And this matrix here is given as half. So this is 0.5 and 0.5. And the next thing that we need know is generally this P of Y given X matrix. And this is, we have already calculated it, 0.9, 0.1, and this is 0.2, and this is 0.8, right? Now what we have to calculate, next thing, next line of business is that we will be calculating P of Y. So that calculation is very simple. So what is going to be your P of Y matrix? To determine P of Y matrix, we simply multiply P of X, okay, in this matrix. Sorry, P of Y by X matrix. Okay. So if you do that, what you are going to get? You have 0.5 and 0.5, and this times how much? 0.9, 0.1, 0.2, 0.8, right? And I mean, it's basically a row times a matrix, so it's much easier to determine. So it will be 0.45, and कितना आएगा हमारा पहला term? So this is 0.45 and 0.1. So this is 0.55, and this is going to be 0.4 and 0.05. So this is 0.45. Anyway, I mean, since we are going to have two elements only, so since it is 0.55, this must be 0.45, right? So these two have been calculated. And since Hx is known, Px is known, we can simply determine Hx here. And Hx is basically, you can see here that these two are equal. So we have already done this a few times. So this will be equal to 1 bit per second, isn't it? Sorry, 1 bit per symbol. Right? Probability half है, मैंने morning में ही ये problem solve किया था. You can determine it when they are equal. So log base 2 हुआ तो वो 1 ही हो गया. Okay. And here in this case, this is 0.5 and 0.45. So what is going to be equal to h of y? What will be this value? This is going to be 0.55 times log base 2 1 upon 0.55. Okay. Or in other words, let me use the minus वाला ज़्यादा सही रहेगा. So this is minus 0.5 times 0.55, isn't it? And then you have minus 0.45 times log base 2 0.45. So you can determine this value and let me know what this value is. कितना आएगा वैल्यू बताइए. माइनस मैं कॉमन ले लेता हूँ यहाँ पे. And what I will have is 0.55 log base 2 0.55 plus 0.45 log base 2 0.45. कितना आएगा बताइए. Anyone? Base 2 का फॉर्मूला नहीं है क्या है? कोई निकाल रहा है कि आप लोग सब भाग गए इधर से? प्रतीक, Shreyash, Narendra, Akshay. Is anyone else there? Prajakta, Amulya, बताइए. Sandeep. Has anybody calculated this? Tushar, आप बताइए. Okay, so this in this manner you can calculate this. This is also going to turn out to be positive. And after that, you will be determining. Divide करना पड़ेगा. Log लिया है.
Sir, 2.66. Minus 2.66.
No, no, it's going to be positive only. You see that this value will be negative here. Right, so negative and negative क्या हो जाएगा? Positive हो जाएगा. So it will be 2.66 only. Sorry, bit per symbol. Okay. And once you determine h of I, and I'm just showing you what you can do, what kind of question can be asked. Then after that, we have to determine, let's say, P of y given x matrix. Now to determine this matrix, we will multiply this PD of x, diagonal matrix of x, okay, and times P of y given x. Okay, so what is going to be P of diagonal of x? This is basically, sorry, this is x, not x by y. This is P of x comma y joint matrix. So this is going to be 0.5. This is 0. This is 0. This is also 0.5. And this matrix we have already, we already know this is 0.9, 0.1, 0.2, 0.8. We will multiply them with this, and what is it that you will be getting here? So you will be getting 0.45, and here it will be 0.05, and then we have 0.1, and then we have 0.4, right? Or had I made any 0.5, matlab 0.45, right? And this 0.05, 0.1, and this is 0.4. Yes, okay. I mean, summation of all of them should be, since this is a joint matrix, summation of all of them has to be equal to 1, and this is exactly equal to 1 here. Okay, so this is the matrix. Now let's say I had to determine this entropy. So h of x comma y. So this will be, again, you see, minus, you take outside 0.45 log base 2 0.45 plus, I mean, taking minus outside all of them, and then we have 0.05 log base 2 0.05, and then we have 0.1 log base 2 0.1, and then I have 0.4 log base 2 0.4, right? And you will determine this h of xy. And once you know this, after that, let's say I have to determine h of x given y. I have to determine h of y given x. And after that, I have to determine mutual information I of x comma y. So how I am going to data? ये h of x by y कैसे निकलेगा? Can anybody tell me? This is basically h of x comma y. माइनस कितना होगा आपका h of x given y, right? So this is minus h of y, isn't it? Similarly ये क्या होगा आपका जब x comma y minus h of x, isn't it? And this, once you have determined all this, this is very easy. It is h of x plus h of y minus h of x comma y. Do not try to find out entropy or these entropy, these two using the formula that I have designed. This is hard enough, right? And it becomes very difficult. So use these formula, and to do that, you can always use this Venn diagram that I told you. Let me just do that Venn diagram once again. So let me just draw rectangle only, so this can be black. And let me take another one as red. Okay. And so after that, let me just define this as green area is our, sorry. So this is the green area, that is intersection, and let me just define this by, this is the intersection and this is going to be mutual information. This whole black part, complete black part is h of x. Complete red part is your h of y. And this green part is mutual information. So I'm going to simply write, let me just make this bigger so that you can understand. So this is mutual information. I'm simply writing it y. And this part here, which is like leftover part. Okay. Is basically your h of x given y. And similarly, this leftover part here is h of y given x. And then, I mean, this union of this Venn diagram here, this union is what? Your h of x comma y. So you can easily calculate from this Venn diagram, you can easily see the relationship, right? So let's say I had to determine h of x comma x by y. So I know that this is union minus h of y, isn't it? So this is this part which is not in y, isn't it? Is that clear? So this is union minus h of y. So this is going to take care of this intersection part, and I will have h of x by y only. Similarly, if I have to determine h of y by x, then what I'm going to do? I will take this union and I will subtract h of x from that, and I will end up with h of y by x. Is this clear? So in this, and for determination of y, you add h of x, h of y, isn't it? And then you subtract your this union. So what will happen? That while adding h of x and h of y, you have added 2 times I, but when you subtract this union, you subtracted h of x by y, h of y by x, and this I which has been added 2 times, you have subtracted this just 1 time. So you end up with I only, isn't it? So that's why its formula is h of x plus h of x plus h of y minus h of x comma y. Or you can think of this in terms of mutual information in terms of h of x only. So mutual information h of x or h of x comma x given y के term में क्या होगा? I will be equal to h of x minus h of x given y, isn't it? This part h of x, which is complete part, minus the part which is not in the union, not in the intersection, isn't it? So you will end up with the intersection part only, isn't it? So I can be given like that only. Similarly, I can be given in this term as well, h of y minus h of y given x. So I hope that this gets clear, and this will, this will help you remember this formula. And this is very, very important that you understand this very much. Okay. So with this, I'm going to conclude this session now. The only thing that is left here is channel coding theorem, and that is something that you will anyway going to study in the next unit. So channel coding theorem basically means, I mean, it gives you that there exists, I mean, it's theoretical only. So it doesn't have any numerical or something like that application, but it is sometime asked. So I hope that this is clear. I will share this lecture notes to all of you, so you can take it. And if you have any confusion, you can always reach back to me. Okay. So thank you for joining in. I'm going to end this session from my end. I hope. Yes.
2 minutes.
Yes.
Okay. ठीक है, and thank you Sumit sir. I'm going to stop the recording now.